So today I got my exam back and I thought I would make a video about two tasks. By the way, I'm such an idiot and I forgot to put on the microphone, so I am recording the audio afterwards. So if there's anything not as accurate as it should be, I know it. Yeah. But the first question we have here is a racing driver follows a racetrack exactly along the dotted line, and at the point P he loses control, and which means he only continues in a straight line, as you saw here in red, and hits the red bar at the point Q. Yes. So what I'm gonna do first, I can only explain it when I see something here. So yeah, maybe you can say the function green is 0.8 times x minus 2 squared plus 1, and the point where he throws out of the line is at 2.5 and f of 2.5. So first we search for epsilon, and how we're gonna do this, we plug in 2.5 in every x we can find. So we put 2.8 times x squared minus 4x plus, there actually needs to be 4. I wrote it false, but I'm doing it right in 3 seconds. Yeah, so then we multiply this out. Now I see it. Yeah, but you can find the y coordinate very faster than I make it here. You can just put it in the green function, so you can put 0.8 times 2.5 minus 2 squared plus 1. This is way faster than in the than putting it in this function. But anyways, I'm so angry at myself. Why I recorded it with the iPad function, and afterwards I put it on my MacBook and I thought, why is there no audio? And then I looked back at the screen recording and I saw, oh shit, I didn't put on the microphone. So the the y coordinate is at 1.2, so this gives us the point P 2.5 and 1, 2. At this point, the driver loses control and continues in a straight line until he hits the red bar, and this is the question. We need to find the point Q, so the intersection between 4, the linear function at 4, so y equals 4, and the tangent, because he falls off in a straight line, we have to derive the function at the point, and this gives us the point where he hits the barrier. So next, I think I take the first derive, yes. which gives us 1.6x minus 3.2. And now we plug in the point, I think. And now here you can see you put the exponent in front and subtract 1, so 2 times 0.8 times x to the power of 2 minus 1. So we get the 1.6x. And if we only have some constant times x, the x gets away, and constants also get away. So now we plug in the point f prime of 2.5 equals to 1.6 times 2.5 minus 3.2. M is the gradient. I call it M, so f prime of x is equals to the gradient, and we're gonna search for this. So at the end, the slope is at, or the gradient is at 0.8. And now we have to write down the general form of a linear function. So y equals mx plus some constant t, where is the m is the gradient, t is the section at the y coordinate, the high or the low, and y and x are just the coordinates we plug in. And yeah, so we plug everything in, so only t is left, so we search for t, and t gives us at the end, we can multiply 0.8 times 2.5, which gives us 2. So we subtract 2 on both sides, which gives minus 1.8 equals to t. And now the linear function is the gradient we get there, put it in, 0.8 times x minus 0.8. And now we just have to set it equal with the red line. This is just a red line at y equals 4, the linear function 4, g of x equals 4 equals y. So we have to set 4 equals 0.8 x minus 0.8 and have to search for x to give us the x point, and this is then the point Q where the driver hits the barrier. So 4 equals 0.8x minus 0.8. We add 0.8 on both sides, which gives us 4.8 equals 0.8x. Then we divide both sides by 0.8x, and this gives us 6. If you do not have a calculator, you can also do 48 divided by 8. This is also 6, and then you put, because before they were 1 comma, you put 1 between. So x equals 6, and we know the linear function is at 4, only at 4, so y equals 4. The epsilon at the y point is at 4. And now I am doing another exercise. Can actually go a little bit further. Next exercise is to derive this function with we derive x and treat a as a constant. So yeah, as I said before, we put the exponent in front of the x and subtract 1, so which leaves us with 4x to the power of 4 minus 1, which is 3. So 4x to the power of 3 minus a to the power of 3 we treat like a constant, so nothing happens with that. And with x to the power of 2, we put the 2 in front the x and subtract 1, so 2 times x to the second power minus 1, so to the power of 1, which doesn't matter. And x to the first power, we put the 1 in front, so which gives us just 1, and x to the 0 is, so which leaves us with just minus 1. And constants like 1, you see at the end there, we always get rid of this when we derive. So now we can simplify and cancel out 2. So a over 2 times 4, we can cancel out the 2, which leaves us with 2a times x to the third power minus a to the third power times 2x minus 1. And just before the end, last but not least, we have the last function f of x equals x to the power of n 2n plus 1. So as always, when we derive the function, we put the exponent in front, so we write everything down and put it on the front, so it gives us 2n plus 1 times x, don't forget the brackets, and subtract 1 from the exponent, so 2 times n plus 1 minus 1, so plus 0, so that gives us 2n plus 1 x to the power of 2n. And yeah, this is my second video. I hope you enjoyed it. I'm not the best yet, but I'm trying my best. Hopefully I don't forget the audio next time. And I'm trying to upload videos every day. I don't know if it's possible, but I'm trying my best, and see you next time.